All right, I'm going to take you through a demo of some dummy drone software that is vulnerable to the Urgent 11 vulnerabilities. And we're going to exploit that and then recompile with RunSafe Protect in place and show how our protection prevents exploitation of this vulnerability and other memory safety vulnerabilities so that even though this is a patched attack, similar attacks on unpatched vulnerabilities that are out there or maybe out there in the future are also mitigated by us. So first things first, I've got a VxWorks board connected to my computer that I am talking to via serial. So I'm going to boot that up. And once that boots up, I'm going to use my administrator command prompt over here in the top left to send some packets that are going to exploit a buffer overflow using that Urgent 11 vulnerability I mentioned earlier. And it's going to cause this drone to self-destruct. And boom. So what I'm going to do now is quickly walk through the installation steps for RunSafe protections on VxWorks target. And this is going to be in the bottom right terminal. So just going to run our RunSafe install script and make sure I do it in the right directory. And run the build prep script. Run a clean build in the VxWorks development shell. And once this build completes, I will jump back over to the VxWorks board, restart it, and send a slightly modified set of exploit commands to account for how the addresses have moved after recompilation. And we'll see that the buffer overflow is no longer a useful exploit. We'll also see this main task here, which is just a function, an arbitrary function in the software. Its address is going to start moving around after our protections are in place. Just an example of the moving target defense that we enable. All right, so this is rebuilt. Go ahead and boot. And as mentioned, that main task is now at a different location. And running the RunSafe exploits shows that we're no longer able to get that self-destruct function. We're able to only crash the program, but not do anything meaningful. So if this drone were to be flying and we wanted to run a self-destruct command, we could not do that. Or, hijack the controls and make it fly somewhere else and then self-destruct. We can't do that. All we can do is make the program crash, which is not inherently useful. So let me just reboot that and show that this main task is moved to a random address each time it boots, and we're not just moving it once. And yeah, this is different than the A8 address. Now it's a D1 address, and every time the randomization would occur on startup, all of the functions, including the entire VxWorks kernel, are going to be shuffled around and unexploitable.